this video, we're going to take a look at writing equivalent rational expressions. All that means is we're just going to write equivalent fractions. So they're going to give us one fraction, and then they're going to tell us what they want the new fraction's denominator to be. So here's my first fraction. I've got x minus 7 over x plus 8. Now the new denominator, or the equivalent fraction's denominator, is going to be x cubed plus 8x squared. Now, one thing that I can do is I can see that they both have an x squared term. So I'm going to go ahead and put this in factored form. If I take out an x squared, that's going to leave me with an x. Take out the x squared, that's going to leave me with a plus 8. So on the new fraction, the denominator's still going to have the x plus 8 like the original one did, but it's also going to have an x squared. So I'm going to go ahead and write down the first fraction again. So x minus 7 over x plus 8. And we want to see what's the new fraction's denominator going to be, which is this x cubed plus 8x squared. So the only thing that's different between the two is it's still the x plus 8. We just also need to have the x squared. So if they multiply this original denominator by an x squared to get this term, then that means I also need to multiply this by an x squared as well. So I'm going to make sure that I multiply that as well. So that's going to give me an x to the third minus a 7x squared. Okay, so this fraction is equivalent to that one. This is just the simplified form of this. All right, let's look at the next example where I have a 3x squared over a 3x minus 6. Now, one thing that I can see on the denominator is that I could divide out a 3 from both of those terms. So let's look at that. So that would leave me with an x. If I divide out a 3 and I divide out a 3. Okay, so this denominator is truly this one in factored form. Now the new denominator, they want us to have all of this. And so one thing that I want to take a look at is that these two are pretty similar, but they're a little bit different. So first of all, let's put this one in standard form, just so you guys can see what that looks like. So if it was negative x and then the constant, I can see that these are not the exact same thing. However, if I divide out a negative 1 from this, so negative 1, take that out, that would leave me with an x minus 2. Then I would have the same factor. So the new denominator is going to have a negative 1, an x minus 2, and then it's also going to have that x squared plus 9. So looking at the first fraction, and I'm going to go ahead and write it as that 3x minus 2. Okay. Their new one, they want me to have it as 2 minus x, which is the same thing as this. Okay. And they also want me to have the x squared plus 9. All right, so one thing that I can see up here is, remember these are separated by multiplication. And a 3 divided by a 3, that would cancel out completely. So I can go ahead and simplify that. Because in the new denominator, they didn't have a 3 at all in the denominator. So that was kind of my cue to simplify that. All right, so if this is what I have left on the first fraction, and the new fraction needs to have the negative 1, the x minus 2, and the x squared plus 9, I can see that I have this already, so I still need to multiply by a negative 1 and the x squared plus 9. Okay. So if I multiply this by the negative 1 and the x squared plus 9. Okay. Again, I could do that down here as well. Okay, then, again, this is the same thing as that, and then I have that. So here I've got a negative 1 times an x squared. So I've got the negative 1 x squared and then the x squared plus 9. All right, so our final answer is right here. Okay, so again, remember that this is the same thing as that 2 minus x. Okay, let's try another one. All right, so this one, they want the denominator to be x squared minus 16. And then remember, this is the difference of two squares, which factors into an x plus 4 and an x minus 4. All right, so this statement and that statement are equivalent statements. So if they give me the fraction x plus 1 over x plus 4, and we want the denominator to be an x squared minus 16, which again is the x plus 4, x minus 4, I can see that I already have the x plus 4 on the first fraction, so I would also need to multiply it by an x minus 4. Okay, so to jump from this fraction to this fraction, I need another factor of the x minus 4. So if I multiply this by an x minus 4 and this by an x minus 4, then my denominator matches up. So my numerator would be the x plus 1 times the x minus 4 over the x squared minus 16. This fraction is equivalent to this fraction. This one's just not simplified. All right, let's look at the next one. So they say, let's look at the expression 5 over 5x minus 25. And one thing that I can see is that I'm going to factor out a 5 from that. And then I'm left with an x minus 5 if I divide that out. So their new denominator, they want me to have the x minus 5. They also want me to have an x plus 1, which means this 5 is no longer going to be part of the problem. So again, this means multiplication. So I've got a 5 divided by a 5. So those will technically cancel out. So now in my numerator, I've got a 1 over an x minus 5. But they're telling me on the equivalent fraction, I want a denominator of x minus 5 and x plus 1. So that means I need to multiply this fraction, this first fraction, by an x plus 1. So I'm going to multiply this first fraction by an x plus 1. Then this denominator matches that denominator. And 1 times that x plus 1, I can leave it as 1 times x plus 1. Okay. You guys do not need to worry about canceling these out, because if you canceled those out, you would be back at this stage. So all they're wanting is just the equivalent fraction that's not simplified.